explain you something. So, actually, if you go to my channel, I'm live there, and you can see my screen right now. Just try to check it out. And here on the screen, I can show you actually something about the graphs, okay? The straight lines. I think that will work better. Daniel Dallas. Daniel Dallas. I can send you probably. Oh yeah, perfect. But actually, because you can mute the sound, right? You can mute the sound. Yeah. And what I'm going to tell you one more time, I'll try to describe the straight lines, okay? It will be much better. Okay. So, the typical equation for the straight line, you have several forms for that. The first form is what is called gradient-intercept. We just recap this basic because they are very significant, okay? So that's mx+c, all right? Yeah, I'm writing on the screen, but I mean, you'll see that on YouTube, maybe with a little delay. Yeah. Or if you like, so I'm not sure, so you can, I don't know the best way, but I think right now it's okay. So we have the gradient-intercept form and two coefficients, m and c. They're responsible for some features of the graph, right? For example, coefficient m that stays before x, do you remember what it is? It's the gradient, yes? It's the gradient. It defines the slope. How graphically we can describe what gradient is? So for example, we have, say, a straight line, say it goes like this somehow. And let's mark some coordinates that your line L with this general equation has for y and x-intercept. For example, here and here. So 1, 2, 3, 4, 5, yes. It starts from 5 for y-intercept, and then it goes to 1, 2, 3, 4, 5 here, okay? So both x and y-intercept have the same values. So what it means, how we calculate the gradient. Do you remember? So gradient by definition is change in y over change in x. So that means we have basically the ratio, how the function, so we take in 2 points, let's say a point and point B on y and x axis. And then we just simply have the ratio delta y over delta x. So how much your function dropping down when you come from point A to point B, okay? It's something like this, yeah. So you have change in y. In this case, it's -5. And you have change in x, which is simply 5. It's +5. So every time you can arrange triangle, and that's how you can calculate the gradients. So that's the basic. In this case, the gradient is negative, and it actually occurs the same, right, for your graph, because your graph is falling. If your graph is falling, the gradient should be obviously negative. Okay, so that's an idea. So next part, what about other stuff? So let's consider coefficient c. So where you can see coefficient c, what it stays for. So you have x-intercept and you have y-intercept. So y-intercept. What do you think about what stays for c? Exactly, is it gonna be x-intercept or y-intercept? No, it's gonna be y-intercept. It's gonna be y-intercept because, look, How would you get the value c? You just simply say that if x is 0, and you plug that in your equation y equals mx plus c, you will get exactly c equals y, right? So if you plug x equals 0, so you can say that it's going to be y equals c in this case, and that means that when x is 0, you're actually on y-axis, on the vertical axis. So that's why your c is actually y value. But you know that when you plug x equals 0 into your equation, you have on the right side c, and on the left side you have the point a. Okay? Yeah, so, and the value for a is 5. So that's why, yes, you'll get c equals 5, and that means that c, the last coefficient, is y-intercept. Alright, so maybe let's go through a little practice, yeah? Yeah, just move there. And I just want to give you, let's say you have the picture, and from the picture you would like to define the equation of the line. So let's say your line is this one, and it goes through maybe like that, through -1 and like this. So you have this value is -1. So you have as the points 0, -1, and you have another point. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 for x, and the same 1, 2, 3, 4, 5, 7, 6. 1, 2, 3, 4, 5, 6. So you need to find the equation for line L1. Okay. So try to determine equation. I'll give you some time for that. Yeah, what do you think about the equation for the line L1? So you think that 5x plus 1. I think we can establish the gradient-intercept form y equals mx plus c, right? And first of all, this coefficient that you can determine is the coefficient c, right? Because c is always y-intercept. Yeah? Let's have a look at your line L1. It crosses y-axis where? So your line crosses y-axis at which point? I mean, remember C stays for y-intercept, yeah? So where's the y-intercept occurs for your line? Now, that's not y-intercept. This is another random point with coordinates 8 and 6, yeah? But you have another point with coordinates 0 and -1. So, what stays for C in this case? So this is exactly y-intercept. So that's y-intercept. And this is exactly point with coordinates 0 and -1. That means you have y-intercept here. So your C is -1, yeah? Okay. So that's why first that you have the first sketch or first draft of your equation is mx minus 1. Okay, so you put the value instead of c equals -1 because it's y-intercept, and you clearly see this point, so it's here. And now you need to find the gradient. That's the second step. How to find the gradient in this case. Yeah. So for example, you starting from the point 0, -1 and go rising to the point 8.8 and 6. So that means you will have a run and a rise, yeah? Yeah, that's like standard and classical definition of what slope is. So you'll have the rise of your function, because your function is definitely rising, and you have the run, which is delta x simply. So this is raise, and this is run. Run is always horizontal. Okay? So what stays for, let's say, a raise, in your case, delta y. So you have from that level, from -1, it has the rise up to 6, right? Yeah. So how many units? First you need to reach 0 level, and then on top of that there are 6 units more, right? So that's why in total you have the rise for 7, yeah? From -1 to 6. Okay. So your delta y or rise is 7. What about delta x? No. Horizontal one, yeah. That's horizontal run. So from 0 simply to 8, yeah? From 0 to 8. So you have 8, okay? And now you just divide in 7 over 8. That's how we can find the gradient, okay? So simply, yeah, 7 over 8. That's the gradient. I understand that this is fractional number, so you can actually calculate using calculator, but let's stay for a while at 7 over 8. So that's why your final equation for that is what? So final equation. Mm-hmm. 7 over 8, x minus 1. Yeah, because your gradient is 7 over 8. Okay. So that's your final equation. And we have another question. Question 2, you need to find x-intercept. So that's question 2. You need just to find x-intercept. So x-intercept is the point where you have intersection with the x-axis. So this is x-intercept. So where your line basically cross the x-axis. And this is definitely the value for x. So where the line cross x-axis. Okay. So what we need to do in this case, I understand that you probably never did this question, yes, because this is harder, but you understand if the line crosses the x-axis, what you can say about y value? Y is 0, right? So that's why into your equation, you can plug y equals 0, so you can say that simply y is going to be 0 in your equation, and that means you'll have, after plugging, you'll have 0 in the left side and 7 over 8 x minus 1 on the right side. Okay? Yeah. And how would you solve that? Oh, yeah, just for a while, I guess. Yeah, but you have an equation right now, yeah? 0 equals 7 over 8x minus 1. How to solve this equation? Simply, what do you need to do? You just need to find x. So, in other words, you need to make the subject. So, make x as the subject, right? But the problem is this equation is fractional. I mean, you have fractional coefficient before x. Yeah? So how to get rid of this bottom part? You don't want to have fractional coefficient, those 7 over 8. So you can simply multiply both parts by 8, yeah? Can you? Because you understand that 7 over 8 will be cancelled in this case, yeah? Okay, if you multiply both parts by 8, 0 by 8 is 0, the result is 0, and the right side, 7x over 8 multiplied by 8 will simply cancel 7x over 8 multiplied by 8 will simply cancel your 8s. And minus 1 should be also multiplied by 8, so you'll get negative 8 finally. And now you're just doing, you canceling those two 8s. Okay? Yeah, understand, maybe this formulation of the problem, it's quite tricky, yeah? This might be challenging, so okay. But we'll consider right now how to convert from general form into gradient-intercept, because you're also given some examples in general form, right? Okay, so let's finalize that. So 0 equals to 7x minus 8, or 7x equals to 8, from where x is 8 over 7. So from where x finally is going to be 8 over 7. And this is positive number, so your x-intercept is that point, and this value is 7 over 8. Okay. So that's an idea. That's an idea how to solve the equation and how to find critical points. So for example, when your line crosses the x-axis, for example, it's something like this. Yeah. Yeah. Maybe let's go to general intercept form, because general form of the line and how to convert into gradient intercept. That will be, I think, fruitful for you. So this is y, this is x. And normally we have, let's say we have an equation in gradient intercept form, y equals 2x minus 1. And you want to convert this equation in the form ax plus by equals c, or equals d, no matter which coefficient you use. However, you need to understand that a, b, and c, they're just numbers. They're numbers. However, in most questions for GCSE, you'll be asked that numbers should be positive or negative integers. In other words, numbers are from z plus minus. So that's what I denote integers. Okay? They might be positive, they might be negative. Okay, so how to convert gradient intercept form, gradient intercept into general equation. How to do that? So you just need to rearrange terms. So for example, you have y on the left side, 2x minus 1. So you simply want to have x and y both on the left side. So that's why you transfer 2x to the left side and you need to swap the sign. Yeah, you need to swap the sign to the opposite. So that's why you'll have negative 2x plus y, and on the right side, negative 1. So in this case, you can say that coefficient A is simply negative 2, coefficient B is positive 1, and coefficient C is negative 1. However, for example, another student decided to do a bit different thing. He decided to change or transfer y to the right side and minus 1 to the left. So for example, from the original equation, 2x minus 1 equals y, he decided to transfer negative 1 to the left side and y to the right side. And he will get 1 equals to 2x minus y. Or if you rearrange then and say, okay, 2x minus y equals 1. That's what he got, okay? 2x minus y equals 1. Yeah. So in this case, like, what do you think? You have, let's say, finalized general form, negative 2x plus y equals negative 1, right there. And another student, has this form. Who is right? Who is wrong? Or maybe you both wrong, or maybe you both right. How to judge? Yeah, two options, yeah, in boxes, actually. Actually, they both correct. You're both correct, because no matter, the general equation might have several ways to be written, but the main idea is to first have numbers a, b, and c, integers. In most cases, you will be asked so that a, b, and c should be integers, and after that, no matter which way you choose, okay? The main idea and the main purpose is to combine x and y on one side and number transferred to the right, okay? Okay, maybe let's practice a little bit. So I'll just squeeze a little this region, and let's try to practice with the following. So for example, you have gradient intercept form, again, minus x, and let's say plus 1 over 2. And the question is, so please make the general form. Okay, so you need to make general form from gradient intercept. So this is gradient intercept form. And you need to you need to rearrange so that to express actually x and y through the numbers through the free coefficient 1 over 2. y plus 1 over 2. But you need to collect both x and y on one side. Yeah? Yeah. Yes. So you transfer negative x to the left side, and you'll get x plus y, right? And on the right side, 1 over 2 you can leave with no problem, yeah? Okay. But you would like to have all coefficients in general form of the straight line to be positive or negative integers. So a, b, c should be positive integers. So how to make them? Right now you have 1 over 2, and that's the problem, right? So 1 over 2 right now is sort of fractional number, but you would like to have as the whole or integer at least. Okay, so what's the best way how to make, instead of 1 over 2, just yeah, right, by by 2, that's enough. Yes? Just by 2, because you have the bottom part 2, you have denominators 2, so you multiply by the same denominator. So that's why you'll get general equation of the line. That's pretty good. So the left side is also multiplied by 2, so that's why you'll get 2x plus 2y equals 1 now, right? Yeah, that's an idea. That's an idea. And let's try the last one. Let's try the last thing here is to convert from general equation. So we are going to convert from, right now, from general equation, general form, into gradient-intercept. Into gradient-intercept. And probably then plot the graph. Plot the graph. Okay. So, for example, you have general form, negative 2x plus y equals 3. Okay, that's first question. And the second, for example, a bit more complicated. Say 3x plus 6y equals 4. Okay, so you need to get the gradient intercept form for each one, because right now you're given general forms, and then we plot those graphs quick. Okay, so first one, negative 2x plus y equals 3. Yeah, what are you supposed to do? Yeah, it should be resumed, I think. Yeah, so you remember that your general form should look like y equals mx plus c. So that's why your goal is to express y through x and through the number. So that's why make y as the subject. No, you're just taking, look, you're taking negative 2x and transfer to the right side, yeah? So negative 2x will be swapped into positive 2x, and then on top of that you add 3. Yeah, and this is already gradient-intercept form, right? So y equals 2x plus 3, okay. But for the second one, it's a bit tricky, because here you have 3x and 6y. So first, I think logically you need to express 6y, yeah? Okay, so let's try to do that. So let's try to express first 6y and negative 3x, because you need to change the sign, yeah. Yeah, okay. And now, finally, you need to express y, so make y as the subject. So how to do this? Yeah. You cannot transfer because between 6 and y you have multiplication, so that's why you need just to divide by 6 both parts, right? By 6, you divide by 6, yeah? So that's why minus 3x over 6. Yeah, and 4 as well, you need to divide by 6, because you cannot divide only one term. You need to divide each term by 6, okay? And now, so this is almost the gradient-intercept form. However, you can simplify, so just make it simple, right? Simplify and say that you can cancel 3 and 6. Or if you have calculator, for example, if you're supposed to do such problem using calculator, you just simply divide 3 by 6, right? And 4 by 6, yeah. If you most stick to the calculator problems, okay, just use calculator and divide. But I would do, for example, some part mentally. So first I will have negative 1 over 2x or negative 0.5x. And then the last number is 4 over 6. I just simply cancel. That makes me have 2 over 3. Okay? Yeah, so that's how it works. And that's the main idea, how you can convert. And finally, let's plot a quick. So just lay out the graphs. So I just put a box around so that we understand which graphs we are plotting. Okay. This y, this x. Okay. Let's start from L1. This is L1 and this L2. So L1 is the top box. And let's try to plot 2x plus 3. Yeah, I'm here. Okay, so 2x plus 3. Let's do quick. So your 3 is gradient. So this is gradient-intercept form. So that's why 3 is y-intercept, yeah? So that's why 1, 2, 3 is going to be 1 point here. And with the gradient too. So there are two ways. Either you can lay out the gradient, so it's quite simple. So for example, if I use arrows, I can show you how you can restore the gradient. So let's say you're starting from 3 because it's one of your points. And let's say you make a unit step horizontally. So that means you make a run. Yes? So just lay out this error to 1, actually, just like this. And because your gradient is 2, so gradient is 2 means you'll have a run as 1 and a rise for 2 units up, right? That's what the gradient tells you. It tells you that you will arrive to the point with coordinates 1 and 5 here. And then you just simply connect with straight line those 2 points, not with arrow, but with straight line. Like this. Okay. This is going to be L1. Okay. So, and L2 simply can use the same approach. 2 over 3, yes. It's somewhere here. So 2 over 3 somewhere here. 2 over 3. That's, again, y-intercept. So y-intercept, yeah. And with the gradient negative 0.5 or 1 over 2 goes down. So in this case, instead of like using the gradient, what I would do, I just say that I can plug any value instead of x. Let's say x equals 2. And that's how I can find it. So I just combine gradient and just mixture of the data table. So if I plug x equals 2, why I've chosen 2? Because I know that 2 times 0.5 is 1, right? Very good number. So that's why I'll get negative 1 and plus 2 over 3. And finally, I will get negative 1 over 3. Or if you calculate using calculator, you'll get the same answer. So negative 1 over 3, that's going to be the point. So 1, 2, that's x. And that's negative 1 over 3. That's another point. And you just simply drop the line from those 2 points. From 2 over 3 and it goes through negative 1 over 3 for y and 2. So that's your L2. Okay? It's done? Yeah, okay. So I hope you understand this at least somehow, right? At least somehow, because this is more advanced, more, advanced level, more advanced. Because before, what you used to do is just you use the data from the table and just put them on XY set, and that's how you plot the line. Here we discuss a little bit what equations are, how to convert one type of equation into another type for the straight line, okay? Yeah, so hope you like that. Yeah, thanks. Up to Tuesday. Yeah, goodbye.